All right. Welcome, everybody, from nothing to something in 2 hours. This is an ongoing series put on by the Indie Game Academy where we teach people how to make games in Unity with C#. We've had a ridiculous start to today's class. This is actually the, I think, third time that I'm making this introduction. We've had some technical difficulties. This is a live Zoom recording with the Works with Indies Discord server. We're now going to move on, though, because I would like to teach you guys how to make video games. It's like one of my favorite things. So let's do that. I'm going to say one last time, in case somebody wasn't here, if you haven't already downloaded Unity, very important to do so. I'm dropping the link in the chat. Now I should be able to thank the Lord, share my screen. Here we go. All right, finally ready to get started. So what you're actually going to be downloading is something called Unity Hub. And it is not Unity. If you are unfamiliar with Unity Hub, I'm going to do a quick little intro here. Unity Hub was added a couple of years ago and is essentially just like a primary location for all of your versions of Unity and all of your actual projects. So in the olden days, the dark times, we used to have multiple versions of Unity installed if we wanted to use multiple versions of Unity. So if one game was using one version and if another game was using a different version, we had to have 2 installs of Unity on our machine. And that's still kind of true, but at least Unity Hub keeps it organized. So you can see I actually only have 1 install. This is a fresh, brand new computer, as you all just found out. But on my last computer, I had 6 or 7 installs of Unity on the same machine. And you can see that there's actually only 1 project on this machine right now, which is the Snake Tester. But as you guys continue down your game development career, you will have plenty of projects. So really the only things to note about Unity Hub is this is the thing that you use to install versions of Unity. So if you have if you've just downloaded Unity Hub, you're going to hit install editor. And for the most part, you can pretty much just always click the most recent version, which at this point is 2020.3.29 F1. That changes pretty frequently. So even if you get a little out of date, you don't need to worry. For the most part, the way that actual developers, people who work in the space, will do it is they will have the same version of Unity throughout a single release. So once they release version 1.25 of their game, they'll actually update Unity. And then on version 1.26, they will keep that same version of Unity up until they release 1.26, and then they'll update Unity a second time. All right, so today we're going to be making Snake. We're going to be making kind of an interesting, like, quasi version of Snake that is simple enough for people who don't know programming to create in under 2 hours. It has some really weird ways that it works, but we'll get to that when we get there. This is the simple version of Snake that we'll be making. This is the little demo project, and then we're going to make a new project together. So you'll have once Unity starts, cute little snake head that moves around. He's got a little tail, and he can actually turn. And when he picks up these little apples, he gets a little bit longer. And then when he runs into his own tail, he dies. And that's the whole game. Has a little score counter and everything. So that's what we're going to be making today. Very rudimentary introduction to how Unity works. Thanks, Ella. All right. If, by the way, I mispronounce anyone's name, please correct me. You are more than welcome to jump in, ask questions, and do anything like that. All right. So when you're making a new project, the only thing you really got to do is click this new project button in the top right. If anyone is having any problems, if Unity Hub is not downloaded, or if you don't have a license, that's a pretty common one, please let me know. We can pause and talk about that. When you create a new project, this is a very recent addition to Unity Hub. We actually need to re-record some tutorial videos, which is great. They now have new sort of like learning examples for you to play around with, which I recommend you do. A lot of these can be very valuable. So here's a 2D platformer micro game or an FPS, first-person shooter. But for any game that isn't an example game, you just go to this core category on the left-hand side, hit 2D game. This is going to be a 2D game. It's a Snake version of Snake. Come over to project name it whatever the heck you want. I'm going to call it Snake with Works with Indies. And then you can put it wherever the heck you want. I typically recommend, if you're not already a developer, I usually keep all of my development stuff in a single folder that I call Workspace. And there's my workspace, my new folder, and I can create project. This is going to take a hot second, and that's because Unity is real chubby these days. It is a massive project and a massive application, but it is incredibly powerful. You have a little bit of a trade-off. It's sort of interesting. At one of my previous jobs at Lumosity, if you guys know the brain training game company, We actually didn't use Unity, even though Unity was a vastly better tool, simply because Unity is just so heavy and the games at Lumosity are so small. You're typically only playing the game for like 1 to 3 minutes. And if you're only playing it for like 1 to 3 minutes, if it takes 10 to 20 seconds to load, it's a whole heck of a lot of time. Okay, now don't worry too much about this once it imports for the first time. There we go, good. I was worried we had a crash or something. It will not take this long to open again. This is just when you very first make a new version, new game. Okay, so this is what you're going to be greeted with once you make a new project. This is what's called the Unity IDE. Does anybody know what an IDE is? An IDE. We wound up going with Cocos. Cocos 2D, if you're familiar with that. Anybody know what an IDE is? It's like Blue's Clues up in here. Integrated Development Environment. Heck yeah, Mohammed, good job. Yes, no, you're totally right. So yes, an integrated development environment. So this is a revolution in making video games right here, this. And the main revolution is just that everything we need to make our games is pretty much right here. Back in the olden days, we used to make games primarily through text files and then, any other assets, so images and stuff like that. So when you wanted to run your game, you had to run it on an actual device, or you had to download and install a simulator and emulator on your computer. Unity has all of that baked into one, and it's what we call an IDE. There are plenty of other IDEs out there now, but Unity was one of the first to really popularize it. So this is, you can imagine, kind of like your Photoshop for making games. It's got all the tools that you really need to do your game stuff. And those tools are laid out for the most part into these different tabs. Now, before I tell you about each of these different tabs here, project, console, hierarchy, scene, game, I'm going to have you set up the Unity IDE to be similar to mine, just so that it's easier for you to follow the lesson. If you're already comfortable enough with the Unity IDE, you don't need to do this. This is just something that I recommend for newbies. So first of all, I got my scene tab and I got my game tab. Right now, you can only see one of them at a time, which is a little bit of a pain. So you can actually rearrange these tabs. If you click and drag the game tab, move it over to the sort of middle right-hand side. The objective is to have both the game and the scene visible at the same time. It just sort of snaps into place. Then you can do that down here as well with the console and the project. So I'm going to click and drag the console over to the right-hand side and let it go. So now I have the console and the project both visible at the same time. Now, the console also tends to want to take up more space than the project, needs more space. So you can also click and drag any of these middle bars to change the size of different windows, different tabs. So I can make that console much more wider. And it also doesn't need to be this tall. So I'm going to make it a little bit shorter as well. And the last thing I'll do, each of your tabs also has its own settings. So the project down here in the bottom left, I want you to go up to the top right of the project window. Those 3 little dots right there. Those are the settings for this tab or for components, which we'll talk about later. And go ahead and switch that to a 1-column layout. This is basically just a different way of looking at the actual files in your game. That's more similar to Finder or File Explorer. So I personally prefer it, but as always, feel free to do you. All right, so let's talk about each of these tabs. And once again, please let me know if anybody is behind or has a question or whatever. So let's talk about each of these tabs. I'm going to do a quick intro, and then we're going to make a sprite and we're going to make stuff happen. So first of all, Unity is laid out into scenes. Is anybody familiar enough with Unity to know what a scene actually does or is? What is a scene? Simone, you look like you know. Nope. I feel like Mohammed, do you know? What's a scene? The backboard. Almost similar to scenes in Blender or Maya. I'm not familiar enough with Blender or Maya, but probably. Ala is, I think, the closest, a container for assets. For the most part, since Unity is a game engine, the main way for you to think about scenes is as if it was a level. So a scene is kind of like a single visual layout of a thing, which we use very frequently for levels, but we also use it for like main menus and stuff like that. So the scene is a single layout. We're actually going to literally like put some boxes here and drop Mario in if we were making Mario. In this case, it'll be a snake and a little apple that he eats. But this will be how we actually visually manipulate the game. And if we have multiple sort of scenes in our game, such as different levels or different locations, maybe we would have different scenes for each one of those things. So that's what the scene tab is. This is like our behind the scenes. Haha, I didn't mean that pun. This is where we edit stuff. The hierarchy is the just sort of drop down layout of everything in our scene. Just keeps us a little bit more organized and allows us to select stuff. The project in the bottom left is everything that is available to us in this project. So instead of just the scene, like the hierarchy, this is everything in our project. So this is like the library in Photoshop. This is, if we have Bowser in our game, he'll be here in our project, even if we're working on level 1.1 and he doesn't exist in level 1.1. Then the console is like our warning light. If you have any experience with code, yes, I definitely can. Thank you for reminding me. This is the assets folder. It will include, let me get that for you. This includes, whoops. This includes the code for today, which I'll cover as we go, as well as some images and a little handout that gives you information on what we learned today and some sort of next steps. So after you finish this class, what we recommend you do next. Of course. All right. So the console tab, if you're familiar with any kind of coding, this should be familiar to you. This is our sort of like our warning lights or our output. This is going to be the thing that says like, hey, your game is broken. And that's why it's important to have it laid out nice and big down here. Then the inspector is all of the information that there is to know about the currently selected game object. So I'm going to make all of you game developers right now. I'm going to wave my magic pen and I'm going to do it. Are you ready? Here we go. Click on the main camera. So first of all, you'll notice that in the inspector, a bunch of information shows up. This is all of the information about the currently selected game object. Under the camera component, which we'll talk about in a second, you'll see this background and this big blue box. Click that, and you can see that you can change the color of the background of your game. So go ahead and pick a color that you feel like fits the vibe of your version of Snake. Congratulations, Wingardium Leviosa, you're now all game developers. You did it. I'm going for pink. I don't know. It just feels right now. All right. So that's what the inspector does. This will all become more clear as well as we actually move through and build our game. Now, I didn't mention the final tab, which is our game tab in the center here, but I feel like we can probably guess what that is. What do people think the game tab does? You can unmute yourself if you're comfortable. You don't need to type everything. What is the game tab?
Is that the camera preview?
Yes, for the most part. Yeah, this is essentially that's where the game runs. Yes, this is essentially what we call an emulator or a simulator. So this is how your game would actually appear on a phone. So if we currently exported this game and put it on a phone, it would literally just be a pink background, but that would be a completed game. This is what would actually happen in our game. So once we have Snake in here, this is actually where we're going to run the game and play the game. It will actually accept input. This is one of the things that really made Unity this incredibly new, powerful tool when it first came out. There were other engines out there that were doing similar things, but Unity really put it together in the perfect way. Okay, let's do some stuff. So we're going to add our first sprite to our world, which is a 2D object. This will eventually turn into our snake. So in the top left of the hierarchy, I want you to hit this plus button here, big old plus. Go down to 2D object, go to sprites, and then go to circle. And if this, by the way, just says sprite, let me know. You are quite out of date in your version of Unity. You'll probably still be able to follow along, but I'll need to tell you some extra stuff. So you'll notice as soon as I do so, you're going to have three different things happen. First of all, a circle appears in your hierarchy. This is all of the game objects in the current scene. Then you have a circle that actually appears in the scene. And then you have a circle that appears in the game. So the scene, this is where we actually edit stuff, right? So right now I have a tool selected. I could mess with my circle. The hierarchy is just a organized view of what's in the scene. And then the game is actually showing us what our game looks like. So now we have a white circle in our game. So before we do anything to actually turn this into Snake, I'm going to quickly go over the different tools you have to play around with in Unity. These are all in the top left. All the way in the top left is the hand tool. This allows us to drag around the scene because once we start making bigger levels, we're not going to be able to see it all just in one screen here. The next is the move tool. When you have that selected and you click on a game object, by the way, a game object is a special term that they came up with in Unity, and it just means an object that exists in our game. So a main camera or a circle are both game objects because they actually exist in the game. So if I click on the circle game object, I'll have these arrows that appear, and I can move the circle along the two different axes by clicking one of the arrows, or I can move it along both axes by clicking that square and moving it around from there. Hot tip, by the way, if you have any other tool selected and you right click, you will immediately get the hand tool, and you'll be able to drag your around your scene. Next is the rotate tool. It does what it looks like. You can rotate your circle, which doesn't look like it does much right now. But if you rotate it along these two axes, your Y and X axes, weird stuff happens. It sure looks like this circle's in 3D when I start rotating this thing, right? Anybody know why that is? Why does it look like our game is 3D right now? I thought we hit a 2D game.
I think it's because we're still in 3D.
It's a 3D game. It's all a trick.
Oh my God.
What? Yeah. So Unity was built for 3D games first. And I'm not just saying that for a fun fact. That's actually important to know for a couple of reasons. I'll point one or two out today. This is one of them. The fact that stuff is rotating in 3D is because it is actually rotating in 3D. In your scene tab at the very top, there's a 2D button. If you click that, you will switch to the 3D view of your game. And you'll see that your camera is actually offset from your circle, and your circle is indeed rotating in 3D space. So I'll say this twice. Unity was made for 3D first, and it added 2D later. Unity was made for 3D first, and it added 2D later. So like I said, there are a couple moments where that's actually going to matter. I'll point them out when we run into them, but just remember that for later, because that is actually somewhat important. You can switch back to 2D mode by clicking this button here. And by the way, that 3D view will never be something your player sees unless you deliberately show it to them. So it will still look 2D to them. All right. Next one is our scale tool. This does what it sounds like in the same way as the move tool. It scales us along one axis, the other, or both at the same time by clicking the center. Then the Rect tool, this is probably the one that I use the most. This is a transform tool similar to Photoshop or Microsoft Word, where you have your four corners that you can move. You can grab just one side or the other. You can also rotate it by holding your mouse kind of off from the corner there. And you can click and drag by clicking on the circle itself or the sprite itself. So this tends to be the tool that I use the most because it just kind of, it makes the most sense to me. And then the last tool is the patented Insanity tool. This is the move, rotate, or scale selected objects tool. This allows you to do all of the tools at the same time. I don't know anyone who uses this, but I mean, go for it, man. All right. So now that your circle looks crazy, I will show you something else. You may have noticed that as you were playing around with your circle in the inspector, a bunch of values were actually changing in real time. You were seeing the transform here have its position, rotation, and scale all changed. This is an output of what you're actually doing to your game objects, but also an input. I can also change the values here. So for instance, if I wanted to fix the rotation on my circle, I could come into my X, Y, and Z rotations and change those each to 0. And you'll see each time I do that, the circle actually responds. So this is a way for you to get number perfect values if you need them. To expedite this process on any specific component, which once again, we're almost there. I'll tell you exactly what that means in a moment, but the transform is a component. In the top right, there's those three little dots. If you click that and click reset, it will also reset all of the values of that component to its default. So we can fix our circle and make it not crazy looking anymore. All right. Anybody have any questions or having any problems so far? Okay, seems like we're good. Okay, so what are we doing next here? Okay, let's talk about colliders and physics. So in the game of Snake, the snake does not have gravity, right? The snake doesn't fall down. If we were doing our Mario class right now, we would actually apply gravity to our snake. But In order to get collisions working in our world, we actually still need to apply physics to this object. So here's how we do that. And this is when I finally talk about components. Does anybody know what component-based programming or a component-based architecture is? Your faces, Solana, great. All right, well, that's perfect. That's why I'm here. Let's talk about it. So component-based programming basically means that we're going to split up our code into smaller discrete chunks that can stick together to make a bigger whole. So the example that I always use for that is if I was going to program a dog, I would write like the legs.cs and I would write the fur.cs and I would write the lick.cs or whatever, and then I would stick those all in one game object, and now I have a dog. In the olden days, we still use this today, so I shouldn't really say olden days. An alternate style, a very common one, is called object-oriented programming, where we would just write a dog script and all the things about a dog would be in a single script. The reason that we do, can anybody guess actually why we would do component-based programming as opposed to object-oriented? Why do you think Unity decided to do this? Why would we want to write a script with multiple little pieces instead of one big piece? There's two main things. More customizable and keep it simple, better organization. Yeah, those are both totally accurate. So the first one is for fixing bugs. So if we, yes, Juan, you are also right. So if we run into a problem with the licking, if for some reason the dog can't lick things, if that's the bug that we're having right now, then we know exactly where to go. We go to that lick script or whatever the heck, tongue script. I don't know. That's a little weird. If we are having a problem with like the tail wagging, we know exactly where to go. The other thing is reusability. Let's say I want to make a cat script. I wrote my dog script in object-oriented land, and now I got to write a whole new cat script. Dang it. Maybe I'm going to copy and paste, or maybe I'm going to do some like inheritance or something. But still, I got to write a whole new script. For a cat, all I got to do is maybe write like a meow script, and then I can still add the fur and the wagging tail and the licking, and now I've got a cat. So I can reuse these scripts in multiple ways. So our main camera and our circle both already have two components attached to them. And I pointed one out earlier if you were paying attention. Can anybody tell me what the two components are on the circle? Yes, fantastic. Mohammed, A+, 10 points for you. Yeah, so the transform and the sprite renderer are our two components. We have a game object that is made up of a transform, which is just a component that keeps track of our physical sort of location in space. So we know our position and our rotation and our scale. You can see that the main camera also has one. In fact, all game objects have a transform. There are other versions of the transform, but they will all have a transform. Anything that exists in the scene needs a transform. And then they have other components that sort of modify their behavior and turn them into something specific. So our sprite renderer renders a sprite. It renders an image. So essentially all the circle is a thing that exists in space. It has a position and it is able to render an image. The main camera is a little bit more object oriented. It has a component that is specifically a camera. It does all the camera stuff and you drop that on the camera object. So in order for us to make our circle have physics, which will actually make it fall into space, but we'll fix that in a second, we're just going to add a new component, a thing that does physics. So on our circle, click your add component button, go down to rigid body and type in rigid body. And you'll notice that there's a rigid body with a blank and there's a rigid body 2D. This is one of those moments where it matters that we remember that we were built in 3D first. So this blank rigid body is actually our 3D rigid body, which we don't want. That'll do weird stuff. So click the rigid body 2D, and that will actually apply physics to our circle. We can see our physics work if we click our three buttons at the very top of the screen, which I haven't pointed out yet. So in the very top of the screen, there's a play button, a pause button, and a step button. Step button is for debugging. Basically, don't need to worry about that right now. The pause button actually pauses our game while it is running, which can be useful for debugging as well. You mostly don't need to worry about that either, but the last one is definitely important. This is our play button, and this is how we actually run or emulate our game. So as soon as we hit play, we'll see that Unity takes a second to sort of load our game, and then our ball falls to oblivion if we added that rigid body to it. All right. Everybody have a ball that falls to its doom. Thumbs all around? Yeah. Fantastic. All right, great. So even though we did that, we actually don't want our ball to fall. We're going to leave. Does it drop forever? It does indeed. The way that Unity does distance and location, it actually can be infinitely big without taking up any extra memory. So that ball will fall forever. It will never land. It has been dropped into the void. Before I tell you about turning, let's see, what should we do first? Yeah, let's actually let's add another object into our game, which we will wind up removing. But it will be a great example for you to see how stuff works in this game. So first of all, go up to your hierarchy again, hit that plus button, go down to 2G objects, go to sprites, and this time let's add a square into our game. This is going to be a little platform for our ball to land on, just so that we can see how collisions work. Plus button, 2D object, sprites, square, and stick that under your circle. Now, what do we think is about to happen if I hit play? Can anybody guess? It will still fall through. That is correct. So if we hit play, we can always test our theory and see if that's right. If we hit play, the ball will indeed fall and it will go straight through the square. So the reason for this is because basically Unity isn't going to do anything unless we deliberately tell it to, right? That ball, we didn't actually test this, but that ball won't fall unless we add the rigid body to it. So we need to actually tell the ball that we want collisions to happen. So if we click on the circle once again, and we scroll down and hit add component, we can search for a collider. And we'll see that there's all these different options here. Here is the second moment where it matters that Unity was built in 3D first. Make sure you click one of the 2D options. There are many options of the shape of collider we can actually choose. For the most part, all you're going to be doing is trying to pick a shape that fits this thing best. And this is a circle, so the circle collider is going to be what you click. So click that. You will see, it's actually quite hard to see because Unity did it perfectly, but look, there we go. If I zoom way in, we'll see this green outline appears around the circle. If you don't have a perfect shape, it's going to be a lot more obvious. So I can make that more obvious here. That green outline, which only displays, by the way, when I have the circle selected, is our collider. So this shows us literally like the hitbox of this circle now. This is what will actually collide. So I'm going to set that back to 0.5 so it is a perfect size. And then on my square, I will also need a collider because currently it still doesn't think it's supposed to collide with stuff. So if I click on my square and I go to add component and I click box collider 2D, I can now hit play and my ball will fall and land on the square once it loads. There it goes. Nice. All right. This is a great check-in point. Does everybody have a ball that lands on a square? Does anybody have issues or questions? Fantastic. Simone, I'm seeing like a, I don't know if this is right. Do you have a ball? Does it land on a square?
I made a square and then I pressed play and it deleted the square.
Huh. That's not right. You clicked play and it deleted the square. When you click play again, does the square come back? So when you click play again, it will stop running your game and it will reset everything.
Oh, maybe it was running then that whole time.
Hey, this actually brings up, thank you, Simone. This is a perfect teaching moment. So that is what was happening almost certainly. So try again while the game is not running. Simone just accidentally discovered something that's pretty important in Unity, which is that, I'm going to say this twice again. When your game is running or simulating, any changes that you make in the inspector will not be saved. I'll say that one more time. When you make changes while your game is running in the inspector, those changes will not be saved. Unity does that on purpose, while it can sometimes be frustrating. They do that on purpose because they want you to be able to play around with your game and not worry about breaking everything, for you to try to find, appropriate values for your characters, for you to play around with levels and stuff like that. So you can see I can actually manipulate my objects while the game is running. I can mess around with this square. I can rotate it. I can change default values. So I could click on my main camera and make the background a different color. And then once I hit play, everything's gone. All of those changes are wiped. And like I said, it does that on purpose so that you can play around with your sort of little sandbox and not worry about breaking things or losing things. In order to make this a little bit more clear, actually, I can give you a hot developer tip. If you go up to Unity Preferences, the very top of your screen to your Unity, the actual menu bar, if you go to Unity Preferences, and then you can click on Colors about halfway down, we'll see there's this play mode tint right here. And actually, I'm going to make mine red. This is a new computer, so I haven't had a chance to set this yet. But change your play mode tint to something more obvious than just gray. I like to do a light red. So now when I hit play, my whole setup will turn a different color. So that way it's a lot more obvious that I'm currently running the game, and I will be less likely to change something that I didn't want to. All right, let's get going. So we have a ball that falls and lands on stuff, and that's all well and good. But we're actually building a game of Snake. So let's make this thing actually work, which means it's time to do some coding. Oh no. Hopefully everybody is comfortable with that. Don't be scared. Coding can be stressful, but it's also an incredibly powerful tool. While Unity sort of minimizes your coding, it more accurately changes your pipeline a little bit. You are still definitely going to have to code to make your own games. For those who are not happy coding, it is also totally valid for you to get other people to code for you and do other stuff. So let's make our very first script. This is a famous, popular script. And for anyone who has coded before, hyperventilating, for anyone who has coded before, you're going to recognize this. In your project tab now, instead of hierarchy, go down to project and click in the assets folder, and then click plus C# script, and name this script Hello World with an uppercase H and an uppercase W. Anyone who has coded before may have just smiled because this really is quite famous as an example. Hello World, uppercase H and uppercase W. It may take a second to, once you hit enter, to compile. Once you do so, double click on that script. And this is where I may lose a couple of you. So for me, I actually am having issues with this, which is funny. I already set this one. So what should happen is when you double click this, some script editor should open up. So I did have that happen. I just had the wrong one open for me. So I had Sublime Text, which is a code editor that I like. And if you want a code editor, this one's decent, but I actually recommend Visual Studio for Unity. So if you need to download one, download Visual Studio before Sublime Text. Sublime Text is what I use for like random other stuff, editing HTML and crap like that. So it opened Hello World for me in Sublime Text. For this class, if it opens at all, you're great. Whatever you're using right there is fine for now. I definitely recommend Visual Studio moving forward because it's got a nice integration, but don't worry about spending the time to get it downloaded. If you had nothing open, let me know because we'll have to do some setup. The main thing that you're going to need to do is download some code editor. Like I said, Sublime Text is great. I prefer Visual Studio for Unity, and apparently I don't have it set up even though I totally already did this. But if you go up to your Unity preferences again, you click into external tools and you see external script editor right here at the very top. You can click that and go and find your script editor. In this case, I'm going to do Visual Studio. Hopefully this time it actually sticks. It'll take a second to set. And there we go. From now on, when I double click this script, we will actually wind up opening Visual Studio here instead. All right, does everybody have script editors opening when they double click files? Once again, more valuable for me to know that something is wrong now than to find out in 30 minutes that you are hopelessly far behind. All right, so I like to do Windows. There's going to be a lot of shuffling back and forth. I apologize for your tender eyes. Here is a C# script. So this Hello World script is not going to be a part of your Snake game. The whole point of it is for you to understand the intro to C#. A script or a class is a single file that generally does one thing. In Unity, for the most part, you're going to be writing your own custom components. So you're actually going to write, similar to the sprite renderer or the camera.
Sorry, it tried to open Visual Studio, but then it
Mhm.
said I needed to download a bunch of other stuff, and then
Oh,
just
no.
closed. Yeah.
And then it just closed?
Well, yeah, because
Okay.
it said I needed to restart my computer or something.
Oh, no. Well, let's see. So it won't work when you try? What you can try, so if you right click on a script file and go to Reveal in Finder if you're on a Mac, or I think it's like Show in File Explorer on a PC. If you click that, it'll show your actual Unity assets. You can see my Hello World script is right here. When you get to here, you can right click and go to Open With. What options do you have when you say Open With?
Sorry, can you say that again? Show and Explorer, and then.
Yes.
Okay.
Are you on a PC or a Mac?
PC.
Okay. So yeah, I think it's Show and Explorer. It will bring to the actual window.
Shows me Microsoft Visual Studio 2017, Notepad and WordPad.
Crap. when you click, Notepad and WordPad will work, but you will be miserable. When you click Visual Studio, it doesn't work. It tells you need to install stuff and restart.
Yeah.
Okay. Well, why don't you grab Sublime Text? It's a very quick download and it's free. Okay. Let's see. Do I have that open somewhere? In the future, I recommend, like I said, that you get Sublime Text. I recommend that you get, here you go. That is actually not it. Is this it? Yes, this is it. Okay. I recommend that you get Visual Studio and set that up. But for now, Sublime Text will totally work. It just won't have like nice auto-completing for you and stuff like that.
Okay, thanks.
Okay. While you get that set up, I'm going to talk about C#. So this is a C# script. In Unity, for the most part, when you write a script, when you write a new class, those are fairly interchangeable words, you are creating custom components. So actually little blocks, just like our sprite renderer, that you're going to drop on objects that manipulate its behavior in some way. In this case, all your script is going to do is to print a line of text here to the console. So here's how we actually do that. You'll see that you started with two functions. Actually, let me do a quick explanation of the other stuff. I don't want to get too ahead of myself. So at the very top of the file, there are three using statements. For the most part, these are basically imports. This is Unity saying, hey, we need access to these libraries of information. So if you are ever copying someone else's code and it seems like you have everything right, but it's still not working, maybe check their using statements. They might have some import that you don't have yet. The next is the declaration of the class. Whenever we create a new object in C#, we are going to use three words to do so. The first word is our accessibility. This is basically who's allowed to see this thing. In this case, it's a public thing, so everyone is allowed to see it. The second is the type of object. This is a class, so it is an entire script, an entire piece of code. The third word is the name of whatever the heck you're making. In this case, it is the whole script, and we named it Hello World. And in this case, when I make a new class, I am also inheriting, which is something you won't need to worry about if you are a fresh engineer for 6 months to a year. But basically, Hello World knows how to do everything that Mono Behavior knows how to do. All right, next most important thing to talk about is our curly braces. Whenever we have a bracket or a curly brace, they always come in pairs. So we'll see here that we have an opening curly brace facing to the right, and down here we have a closing curly brace facing to the left. These are partners. And in Visual Studio, you'll see that if I click on one, it will highlight the other. And we'll see that this one also is in a pair. This one is also in a pair. Brackets basically tell you the contents of the line above them. When I'm teaching this class, I'm gonna use some slightly incorrect. I'm gonna say some slightly incorrect stuff for the sake of quickly understanding the majority of the concept. So for the most part, brackets designate the contents of the line above them. So we can see here that there's an opening and closing curly brace. Everything inside of this opening and closing curly brace is a part of the Hello World class or script. So here's our very quick example. Is stuff a part of Hello World? Yes. I told you it's Blue's Clues up in here. Yes, because it is inside of the opening and closing curly brace of Hello World. Is stuff a part of the start function? Which we'll talk about functions in a second. Yes, because it is inside of the start function. It is inside the opening and closing curly brace. Is stuff a part of update? No. That's curly braces. It's easy. It's just basically, it's kind of like the punctuation of a code entry. This is how script knows the contents of stuff. All right. Now, in our, whenever we create a new C# script, we always start with two functions. This is start and update. These functions happen automatically. They are called automatically. We can see a little explanation here of both. So start is called before the first frame update. Basically, this happens at the beginning of the game. Update happens once per frame. We all know about frame rate, happens 60 or so times a second. So anything you put in here is going to happen 60 or so times a second. So let's actually do our hello world now. Inside of your start function, in this opening and closing curly brace, I want you to write debug with an uppercase D dot log parentheses, quotation marks, hello world. And then at the end of that, a semicolon. Debug.log hello world. All right. Abigail, you doing okay? Cat burp, you doing okay? Loving the cat pictures? Let me know if anyone is not. Okay. By the way, the text file that I sent, which some people may not have, I can send that one more time for everybody. The resources file that I sent to everybody here includes all of the code that we're going to be going over today. So we can see in this scripts folder, all of the scripts that we'll have here today. We're going to write the completed snake script together, and we're writing the hello world script together. But you're welcome to just use these scripts. So if you're really having problems with hello world, you can just not code for today, and then you can come back to the video later or whatever the heck makes sense for you. That's part of the reason that we have the scripts available to you. So these all work just fine if you're having any problems, or if you need to look at an example and not just my screen. Okay, so this is actually all we need to do in order to get our hello world working. This is going to print hello world to our console down here. Except this is a component, right? How do we use a component? How do we use our rigid body component? Anyone? I'm missing the chat again. Here we go. What do we actually have to do for a component to exist in our world? Add component button. Yes, I was confused for a second, but yeah, it needs to actually be attached to something in our world. Right now, it's like we, I don't know how to do an example except talking about code. Right now, it's like we wrote a piece of script, but we aren't actually utilizing it, right? So in order to utilize it, I'm going to have us attach the hello world script to our main camera. So click on your main camera, come down to add component again, and you should now be able to find, if you search for hello world, your hello world script. This is actually a component. You custom wrote a component. Now, if you can't find it, that means you messed up somehow. And let me know, and we will figure out how you messed up. Once you have attached it to your camera, you can click play. And nothing's going to change in your actual game, but in your console, you will see a fateful, famous message that says, hello world. Congratulations, you have written your first C# script. All right. Everybody have hello world? This is a great check-in moment. Thumbs up, thumbs down, frowny faces, sadness, crying, panic, goodness. I'm going to move on. Anyway. All right, we got some hello world working, which is fantastic. Now, for the sake of time, normally with the hello world script, I have us do a little bit extra to kind of play around with the script. Fantastic, Abigail. I'm glad you're doing well. But for the sake of time, we're going to move straight on to the snake script. So I'm going to explain some concepts as we do so. Thank you, Cat Burp. Amazing name. So we're a little disorganized down here in our project. Remember that our project is like our library. It's everything we have access to, including all these scripts. So even when we didn't have our hello world script attached to anything in the scene, it still was down here in the project, right? So let's get a little bit more organized. In our project assets folder, we're going to click plus, we're going to make a new folder, and we're going to name this folder scripts. And then you can drag and drop your hello world script into that folder. So now we've got two folders, scenes and scripts, and our hello world script is inside of the scripts folder. Okay. Now, in order to make a new script immediately inside of that folder, you can select the folder itself. Not like that, just select it, hit the plus button, go to C# script. And this time you're going to name it snake with an uppercase S, snake. So like I said, even though this is going to be a component, this is going to be a little bit more on the object-oriented side. This is going to do most of the stuff that a snake needs to know how to do. Once you have created a new script, you can double click it and open up the snake script. Now, I kind of would love to not cover this for the sake of time, but it seems like everybody makes this mistake at least once. Let's say that I messed up and I accidentally wrote Sneepo. I was like, shoots, I misspelled that. This needs to actually say snake. This is very important. If I try, watch this. I haven't written any code, right? There's no way that I could have made Sneepo incorrect because it's a totally blank script. But if I click on my circle and I try to add component, there's too much crap in the way. Beautiful faces are all in the way. If I try to add component to a main camera and I search for Sneepo, we'll see that it doesn't exist, and neither does snake. So this is very important. If you ever rename a script, you need to rename it in 2 locations. This is another one I'll say twice. If you ever rename a script, you need to rename it in 2 locations. You need to, first of all, rename the file itself, which is what's in your project, and then you need to rename it inside of the script. So I could actually make this work by renaming this Sneepo and saving the script and then coming back. And now once Unity takes a second to compile, if I click on main camera and click add component, I can't find Sneepo. That's probably because it's a blank script. Haven't tried that before, but that would fix it. There's now no problem with Sneepo. However, we want this to be named snake, right? So we need to, first of all, rename it here this is the name of the file itself. This is what we would see in File Explorer, in Finder. Rename that to snake. And then after doing so, open the file. Unity is taking a second here. There we go. And once this is open, we also need to rename it. It's a great sign. Hold on, let me close that, try again. We also need to rename it inside of the script. There we go. Oh, that's interesting. See, so this is some of the weird stuff that can happen. I actually apparently never renamed the Sneepo file to Sneepo inside of the script. Probably I renamed a fake script that Visual Studio thought it had open because it thought it had the snake script open. So that's some of the weird stuff that can happen. When you rename scripts, this is really all you need to remember. When you rename a script, make sure you rename it here in project and here inside of the actual file. All right, that's enough of that. Let's make snake. So the first thing we're gonna do to make this snake is some input. And by the way, when you're making video games, this is typically where you start. This is the first thing that you generally create, the input for the player. As soon as you can get your game actually running and the player interacting with your game, you can start doing play tests, you can start testing it yourself, and you can start building out more of the game. So the snake is a little bit unusual. The way that our snake actually functions is that instead of like in Mario, where when I hold right, it moves to the right, and then when I let go, it stops moving. In a game of Snake, when I tap right, it will keep moving right until I tap another direction. So this code is going to be a little bit unusual and the tiniest bit more advanced than in any other games, but that's a great way for you guys to learn more. So here's what we're going to do. We actually don't need the start function for our snake script. We don't need to do anything at the very beginning of the game. So you can just delete that start function and nothing will go wrong. Inside of our update function, we're going to do some input. So I'm going to type some stuff out. And what I would like you to do is just copy it verbatim. So if I add a semicolon, add a semicolon. If something's uppercase, do the same thing on your code. And then once I finish typing some stuff, we'll actually talk about it. So here's what I want you to write. If parentheses input dot get key code dot left arrow brackets. I messed up a little bit, but that's okay. Direction to move equals new vector2 -1f 0f semicolon. Yeah, we're getting into some good stuff now. if input.getKey, keycode.left arrow, direction of move equals new vector 2, -1, 0f. As I said earlier, by the way, if you want to, you can open up the completed snake script from the example stuff that I sent you. So that way you can just copy and paste if you're having problems, or at least you can have it up while you are coding so that you're not just trying to copy it from my screen. I'll give you another couple seconds to copy this down, and then I'm going to talk about what it does. Okay, so first of all, we have what's called a conditional here, or an if statement. A conditional or if statement, if you're fancy, you'll call it a conditional. If you are a regular human, you'll call it an if statement. A conditional or if statement basically just does something very straightforward. It just says, if this is true, do this. So whatever is inside of these parentheses, if that is true, so let's say if 5 equals 5, which in case anyone didn't know, 5 does indeed equal 5, then we're going to do whatever is inside of this. However, it is inside of our brackets. However, if what's inside of the parentheses is not true, 4 does not equal 5, then we will not do this. We will just completely skip this section. So what we're doing up here is we're saying, hey, if we have a certain key that we are pressing, in this case, the key that we're asking if we're pressing is the left arrow key. So essentially this is saying, hey, if we are pressing the left arrow key, then I'm going to set this variable, which we'll need to make in a second. That's the thing that I messed up a little bit. We're going to set this variable equal to a new vector 2. Does anybody know what a vector is? Can anybody explain what a vector is? You can, for anyone who was not already here, X and Y. Yeah. So that's a little bit simplified, but for the most part, a vector is indeed just an X and a Y. Has a direction and magnitude. Yes, that is more mathematically accurate. So a vector is essentially an arrow in space. So if I grab my pen again here, and I've got a graph where I've got an X-axis and a Y-axis, a vector is an arrow pointing in some direction here. So I'm starting here at 0, 0, and I'm moving up to, let's call this 1, 1. So that's a perfect 45-degree angle moving up to 1, 1. The way a vector 2 works in Unity, some people do actually use it to indicate positions. So they just use it as an X and a Y. So actually both of you were correct. But in this case, we are actually using it as a direction. So by indicating -1, 0, what we're doing is we're making an arrow pointing to the left. Therefore, we're telling the direction to move to be left. Now, the variable that I forgot to add is this direction to move. So at the top of your class, underneath line 6 here, I want you to make a new line, and I want you to type public. Oh, I lied. Type private vector 2 direction to move. And you'll see as soon as you do that, this line will stop being red underlined because now the code knows what direction to move is. And therefore everything's okay. So all this is what's called a variable. We haven't talked about that yet, but essentially that's just a single piece of information that we're storing somewhere. It has the same 3 words as our class. So it has an accessibility, who's allowed to see it. Private accessibility means only stuff inside of this class is allowed to see it. And I'll show you why that matters in a little bit. Then it has the type. So remember our snake is a class. This is a vector 2, the thing I just explained. It's an arrow in space pointing some direction. And then the name. We can name it whatever the heck we want. That is a valid vector 2, but I recommend you make it as human readable as possible. We are then using that direction to move down here. We're setting it equal to an arrow pointing off to the left. So before we actually get this thing working, we're going to copy and paste this if statement 4 times and then modify the contents just a little bit for each direction. So you can go ahead and paste this one 4 times. And then once you have done so, we're going to go through our 4 directions and slightly modify our direction, our vector for each one. So for a right arrow, keycode.right arrow, I can make my X here, my -1, into a +1. So now my vector is pointing to the right. Then I can do my up arrow. This one does not want to point along the x-axis at all. It only wants to point along the y-axis. So my x is going to be 0, and my y is going to be a +1. It's going up. And then my down arrow is going to be 0 on the x-axis. It's not pointing left or right. And instead, there's a -1 pointing directly downwards. So those are my 4 if statements. That's going to check our 4 different cardinal directions if we have clicked any of those directions. And whichever one gets clicked last is going to wind up being the direction that the snake actually moves. Okay, now we are not going to write code that actually moves the snake. I have written that code for you for the sake of time. We only got 50 minutes left after all. So you are going to be using a separate component. This is very common architecture for 2 components to be interlinked and to communicate with each other. We're going to use one of the simplest ways to interlink 2 components. So what I'd like you to do is, this is where it's going to be important that we actually import files. What I would like you to do is you can download the entire Snake in 2 Hours folder. If you are in the folder here on Google Drive, you can click the name up here and hit download. Some people have had problems with that occasionally. If you do have problems with that, it seems like nobody ever has problems downloading one file at a time. So you can always right-click on just one file and hit download. But go ahead and grab those files because we're about to use one of the scripts that I wrote for you. Once you have them downloaded, where are they? Here they are. Problem with teaching on Zoom is that there are always a bunch of things in the way. All right. So once you have them downloaded and somewhere on your machine, we can see that I have, didn't open, hold on. There we go. We can see that I have the exact same folder from the Google Drive here on my machine. The way that I import things into Unity is very simple. I simply click and drag. So if I wanted that mover script, which is the one that I'm about to use, I can click and drag the mover and drop it straight into the project. I can actually drop it straight into the scripts folder. And Unity will automatically make a copy of this file. So that original file does still exist. It's still here. And it will put it here into your project to be used. So you can go ahead and grab all of these scripts. There won't be, don't grab Hello World or Unity will be upset that you have 2 Hello Worlds. But you can grab the other scripts if you haven't already done so, and you can drop them into the scripts folder. So you should have an apple, a game restarter, a hello world, a mover, a snake, and a snake poo, which will make sense soon. And you may also have a completed snake, which is just the exact script that we're writing right now, except it's all done, so that if you need an example, you can look at it. Let me know if anyone is having problems downloading or importing stuff into Unity. All right, so once we have downloaded the mover, we can actually use it. The way that we're going to use the mover, we're going to do 2 things. Up at the top of our snake file, we're going to create a new line, and we're going to write public mover, and we'll see that it correctly autocompletes it. It knows what a mover is now that we have it imported. And then we can just name this mover with a lowercase m. That's also pretty common architecture. If we just have one of that thing in our file, we can just name it the same thing, but lowercase. You'll see that there are certain rules for sort of syntax with how we write code. All of our variable names are lowercase. All of our function names are uppercase. All of our object type names are uppercase, for instance. You'll start to pick those up as you get more advanced. All right, so we have a public mover, the top of our file. And then down here, underneath all of our if statements, but still inside of the update function, we're going to say mover dot move in direction to move. Object reference is required for a non-static field. Oh, I'm sorry, I messed this up. So the reason that this is upset with me right now is because I'm trying to talk to the type instead of the variable. So it's just because this is not lowercase. Mover dot move in direction, direction to move. So what this is going to do, this is actually communicating with a real mover that we're going to attach to our snake. And the mover, if we wanted, we could open up and look at it, which is something that I do encourage you guys to do later. Try to understand how these scripts work. If it will open mover for us. Hold on. There we go. For many of the scripts, I wrote just a ridiculous amount of stuff about it. So like if we look at the completed snake, for instance, there are tons of comments in there to tell you what's going on and how stuff works. If we open up the mover, basically all this thing is doing is it has a public variable called speed. And then it's taking our position, which is inside of the transform, which we remember every object has a transform and it has a position. And it's literally just adding to that transform. So it's just adding an X, a Y, or a Z to that transform. That is all this mover does. So every frame it adds a little bit to the X, Y, or Z, moving the thing in a specific direction. All right. So this is all your snake should have so far. I'm gonna do a quick review and then we should be able to get our snake moving. So at the very top of our snake script, we should have a public mover. We should have a private vector2 direction to move. And then we should have our update function. Inside of the update function, we should have 4 if statements, each one with a different key code and a different vector2. And then after all of those if statements, but still inside of the update function, we should have a mover with a lowercase m dot move in direction, parentheses, direction to move. Okay, let's get this set up in Unity, and then we'll have a pause to catch anybody up who's having any issues. Our circle here is going to become our snake. It might even be a good idea to name it that now that we are changing it. So click on your circle, and then you'll see in the inspector at the very, very top of the inspector, it actually has a name box. So I could name that snake now. And then you can scroll down to, if I can get your faces out of the way, goodness, there's no good place to put you guys. Put you over here, how about that? All right, at the very bottom of the inspector for the snake, we can hit add component again. And we will need the snake, but we will also need a mover. The snake needs to know how to move. This is like our dog that we were talking about, right? So hit add component and attach both a snake and a mover. And you'll notice that this snake here currently says mover, and it has none, parentheses, mover next to it. So this, we can see actually, is the difference between a public and a private variable. Our public mover is visible here in the inspector for us to manipulate and edit. Our private vector2 direction to move is not visible in the inspector because it is private. No one is allowed to see it who is outside of this class. Now for our snake to work, it needs to be able to talk to this mover right here. If I were to hit play right now, my game would freak out. We can see that I'm getting a ridiculous number of crashes. It's actually crashing every frame. So our game is currently crashing 60 times a second. Bummer. However, the crash that it has is actually, it will become one of your favorite crashes. And the reason that it's one of your favorite crashes is because 99% of the time it means the same thing. I hit play by accident again. Gosh darn it. Hold on here. Great. So it is what's called a null reference exception. Object reference not set to an instance of an object. By the way, because you're building games in Unity, Unity has such a ridiculous amount of support. 45% of new video games, period, all games are made in Unity. You could just copy and paste this problem, and you will almost certainly find somebody else who ran into it and will be able to explain it to you. However, this one's pretty straightforward. A null reference exception, object reference not set to an instance of an object, and it labels it. It tells you it. It says, hey, it's in snake.update function. And not only is it there, but we can see that it's in the snake file on line 34. So if I go down to line 34, it must have something to do with this line. So either it's direction to move, but that's private, so we know it exists, or it's mover, which we can see here in the inspector is not set. So all of that to say, when you run into a null reference exception, 99% of the time, it just means you forgot to set something up in the inspector. And in this case, the snake needs to know who the mover is. And I do that just like when I'm putting scripts in my project. I do that just by dragging and dropping. So I can actually click and drag this entire component just by grabbing its name right here and drop it into that empty box. And now we have created what's called a reference variable. The snake now knows how to talk to the mover component. So this is one of the simplest ways for us to commingle components, connect components so that they can do work to each other. And now if I hit play, our snake actually won't move right away. And that's because we don't have a default value. Oh, it did. Oh, that's because of the gravity. We'll have to change that in a second. But now if I hit left or right, wow, our snake will move left, right, down, and up. Now, in our game of Snake, in classic Snake, you are looking top down, so you don't have gravity. In order for us to turn off gravity, it's actually pretty simple. We can edit anything in the inspector that's available to us right there, right? So we can see on the Snake rigid body 2D, there is a gravity scale variable, and it's currently 1. If you change that gravity scale variable to 0, gravity will no longer apply to your snake, and you'll be able to just control your snake using the arrow keys. However, it still moves crazy fast, so you probably want to turn that value down a little bit. You can turn it down while the game is running, but once again, that means it will not be saved. So I could turn that down to a 0.1 if I wanted to experiment and find the correct value, but it won't save it. So I'm going to try, that looked like really dang fast. I am going to try 0.1. That is 1/10 of the speed that it was before. This is one of the amazing parts of Unity and public variables. We have made a variable that we can play with and make our class more robust. We can now use that mover. So 0.1 looks a little bit more appropriate. I might even slow that down more. We can now use our mover on multiple things. We could put it on a dog. We could put it on a cat. We could put it on an enemy and change that speed variable to change how the mover actually interacts with the character. All right. So that is, we may write more script, but for the sake of time, for now, we're going to use some of the scripts that I already have written for you. This is actually a very important check-in moment, I guess. I'm going to turn down the speed a little bit more, 0.005 or just 0.05. And let's check in with the room. Is anybody having any problems? Does everybody have a circle that moves in directions when they click arrows? Anybody having problems? How's it going, Abigail? How's it going, Mohammed? How's it going, Capper? 2 thumbs way up. Fantastic. Let me know if anyone has issues. Great. It looks like everyone's good, which is very good. Congratulations. Okay. And don't hesitate to tell me, by the way. No one's going to judge you. I'm definitely not going to judge you. I don't like places that do that. Could you click on square? I don't know what you mean. Oh, you just want to see the contents of square? Sure. So the square has a box collider 2D, which is why we're allowed to run into it, if that's what you're wondering. It also has a sprite render and transform. Perfect. All right. So we're actually going to get rid of this square, or we could turn this into the apple, but that is the next thing to add. Actually, let's do this first. Let's add the tail to our snake before we add the apple in our game. So we have created this version of Snake in a really sort of funky way for you guys. And that's for the sake of trying to get it done in 2 hours. What I am about to show you is not the best way to make a game of Snake, but it is a functional way to make a game of Snake. And as a game engineer, you will quickly learn that that's actually a pretty important sort of thing to juggle. Sometimes it's really worth it to spend the time to make something the perfect solution. And sometimes you just got to get it working. We are, in this case, doing just a get it working approach so that you guys can have a working version of Snake with a relatively easy to understand approach. So here's what we're going to do. On our snake, I actually want you to right click on the snake itself in the hierarchy. And we'll see that down here towards the middle, we get the same menu for creating objects. And if we go to 2D, actually, we don't even need that. Go to create empty and then just click that. And you'll see that it does something interesting. It makes something just called a game object, and it makes it kind of indented from the snake. And by the way, you can name this thing tail. This is going to be the tail for the snake. So I'm not going to go too hard into this because I want us to get our game of Snake functional before we finish today. But this is what's called hierarchy parenting. So the tail is now a child of the snake, so that when I move the snake around in my scene, the tail will move with it. So we can see, here's the tail. It currently has no body. It doesn't have a sprite render, but it does still have a position. And right now I'm offset the tail way over here. If I then moved my snake over to here, my tail moves with it. It is now connected as a child. So I'm going to reset its position to 0, 0, which will put it right on top of the snake. And then I'm going to click Add Component, and I'm going to search for Trail Renderer. Add Component on the tail, Trail Renderer. So this thing will actually show you the trail even as you're editing it. And you'll see that wherever you move your snake, it has a tail that follows it. And if you move it enough, that tail eventually sort of clears itself. Currently, it's super pink and ugly and super, super long. So let's do some quick editing to make this a little bit better. First of all, this time is actually how long the tail is. It's a little weird. But this is where we actually want to edit the time. I don't remember what a good default value is for this. Let me check that real quick. Is that in the Apple? Ah, there it is. Okay, so I think a 0.5 is a good default value for that. We'll find out as we go. So change your time to 0.5, and now you'll see as you move the snake, the tail is a little bit shorter. And now you can also, on your tail, mess around with this width slider. So you'll see that if I move this width slider down to the middle there, and then I move my snake, the tail is actually a lot like narrower. It's not as wide. You can actually, this is what a curve is what it's called, and is something that you can mess with in a couple of different areas and a couple different locations, but this is one of them. You can actually click anywhere on this curve. You can double click to make a new curve point. And then if I move that down, I'll have a tail that actually like gets narrower as it goes. So I could start this up here at 1, so it's full thickness. And then as I move, you'll see that that tail gets thinner. And then you'll also notice the tail is super ugly in pink. And even if you change the color, it doesn't care. Here's another hot tip. Whenever you see that super bright pink color, that actually means that you are missing a material. So here under the materials on the trail renderer, there's a little arrow thingy. If you click that, you'll see that it has a none material inside. So that's why it's pink and ugly. Whenever you have an empty box like this, you can click the little circle on the right-hand side of it to see all of the options that are available for that empty box. And if you just click the default particle there, the thing that looks like a little starburst, that's probably going to be best for you. Now, whoops. Now when you move the snake around, it has an appropriately looking tail. Actually, I think for the sake of a snake, that default particle might not be good. Let's do a default line instead. The white square. Go to your material under the little drop down and go to default line. And now when you move the snake, you've got a white tail. There you go. All right. Now you can also mess with colors here. So if you click this color, you can see this is actually a gradient. So I could start the color on a nice green because it's a snake, and then it will get white over time, over the length of its tail. And you can mess with other settings like that. You'll also see, this is actually important and a really interesting point in Unity. You'll see that the tail is on top of the snake. It covers the circle, right? The way to fix that is with Z position. So remember that our game is actually 3D. And if I switch to 3D view and then move my snake, something real funky will happen. It's actually still hard to tell. The trail render is actually in 3D and is currently on top of the circle. If we want to make sure that the trail stays behind the circle, we can actually push its Z position backwards. We can push its Z position backwards. So we can see my Z position is now a higher number than that of the snake. And now in 2D world, if I move my snake, the trail stays behind it because in 3D, it is literally behind it. That is the main way that we use Z, the Z position, in 2D games. We use it as a way of sorting or ordering our game objects. That's only one way to do it. That's sort of the most primitive way to do it. All right. So we now have a trail render that functions, and we now have a snake that moves around. Let's add our apples to the game. Anybody having any problems with the trail render? Let me know if so. Are we good with that? Okay. So let's add some apples to our world. We're just going to use the script that I have written for you for that. So let's add some images into our game. We do the same thing that we did with our scripts. You can open up the example folder and drag that whole images folder straight into the project. And once Unity compiles it, we'll now have an images folder with an apple and a snake head. In order to make our snake look like a snake, we can click on the snake and we'll see that sprite renderer has a sprite that currently has a circle in it. You can drag the snake head from the project right into that empty box there and let go. And that will replace the circle with the snake head. And now it actually looks like a snake instead of, a circle. Now you'll see that this is way too freaking big now. And you'll also, the more astute of you may have noticed that the collider is no longer the correct size. So you're going to want to do a couple of things. First of all, you're going to want to scale it down to a size that feels appropriate to you. So 0.1 looks fine to me. And then you're going to want to reset your circle collider. So on your snake, go down to your circle collider component, go to the three little dots in the top right, click that sucker, click reset, and Unity will once again do its best to resize the circle to be the correct size compared to the snake. Okay. Let's get the apple into our game. Now, we had a blank sprite renderer, just like our square, right? So we can drag and drop the apple here if we wanted. We could also click this little circle like we learned to look at all of the images that are available to us. So for instance, here's the apple. I could actually click that and now wow. And now there's an apple in our world. But another sort of hot tip for you is I can actually click and drag images straight into my scene. And Unity is smart enough to make a new game object with the apple already attached. Now you could use your square. It doesn't really matter in this case. Actually, for the sake of keeping everybody consistent, go ahead and delete your square because we're going to make the apple slightly differently. And then click and drag the apple into your world. And then resize your apple to be more appropriate. So let's see, 0.1, still too big. Goodness, it's a big apple. Make it a 0.02. 0.02 looks about right for me. You can do whatever feels right for you. Now the apple is going to need two things. First, we're going to need to click Add Component, and we'll add a Circle Collider 2D. And then we'll click Add Component, and we will add the apple script that I already attached for you. Okay. All right. So we now have an apple that has a Circle Collider 2D, and it has some score text and a player trail renderer, respawn bounds, and score. So this is how this thing works. First of all, the apple is going to automatically teleport itself inside of these respawn bounds every time it gets touched. This is a script I wrote myself, right? So you can take a look at it yourself later and see how it works. But basically, it teleports itself inside of its boundaries whenever it gets touched. So we have to set this respawn bounds. It uses that for both X and Y. So if we look if we put it sort of at the edge of where we think it should spawn, and then look up at our X position, it looks like it's a 3.28. So you could make your respawn bounds, it's hard to say, maybe like a 3.2. And then every time it gets touched, it'll get randomized a little bit. The other thing is it needs some score text, which I'm going to show you in a moment. So ignore that for now. And then it needs the player trail renderer. So it actually needs to know about the player's tail because it's going to make that tail longer every time you touch it. So in order to do that, you actually have to click and drag the tail object into that empty slot. Click and drag the tail object into that empty slot. The player trailer renderer variable will be automatically filled. It will automatically find the trailer renderer component and drop it into that slot for you. Okay. So let's see. We can do UI. I won't take too long. So let's also add that score text before we test this thing. So this is the land of UI, which can have all kinds of interesting complications. So with it, there are people whose entire job is just to do Unity UI. So in order to add some UI into your world, in your hierarchy, I want you to go to the top left. I want you to click the plus button. I want you to go down to UI and then text, plus UI text. And you'll notice a couple of things happen. So first of all, it creates a canvas, a text object, and an event system all at once, not just text. This is basically just things that are required for the canvas. So the canvas, for the text. The canvas, if you double click on anything, here's another hot Unity tip for you. If you double click on anything in the hierarchy, it will zoom the scene to be looking at it. So if I double click at the canvas, we'll see that it's this massive thing and that it is exactly the same shape as our game. The canvas is a container for our UI. And the reason that Unity devs do it that way is so that we can more easily compensate for different screen sizes. So all of our UI always exists inside of a canvas because this canvas is really good at being resized. And if I actually change the size of my game, which hypothetically is like me looking at a different size device, right? We can actually see the canvas responding to that. Now, our text is currently in the very bottom left of the canvas. And even though the canvas looks humongous, the text looks the correct size on our game. This I've always found a little bit weird, but is how it is. The canvas is actually the exact same size as the game. They just make it humongous, I think, so that you are kind of in a different space when you're editing it. But either way, it's huge, but it still matches one-to-one to the actual game. So what I want you to do is click and drag your text to be up at the very top left of your game. And you'll notice that when I resize, the text doesn't care about being resized. It kind of sticks itself to the center of the screen. And if I was playing on too narrow of a device, the text would actually go off the side of the screen. In order to fix that, I want you to position the text so that it looks nice. And then if you click on the text, go to the inspector, you'll see that it has the rect transform instead of a regular transform. And it has this sort of like maybe targeting looking thing, like a targeting reticule or something. If you click that, you can actually change the anchor point of this text. Currently, it's anchored to the center of the screen. If you anchor it to the top left instead, and then you resize your screen, you'll see that this time it stays in the correct position. So that is like super quick introduction to Unity UI. It's actually quite a complicated subject, and I feel like we could do a whole rundown on how it works. All right, so this is going to be our score text. We actually don't need to, well, I guess we should. So you can rename it whatever you want. I renamed it score text just to make it more clear. And then if we come over to here in the inspector, we'll see that just like any other object, we have all kinds of stuff we can play with here, including the default text, which is this text box. The apple is actually going to change what that text box says. So this is only going to be your default text, whatever you write in here. But I'll write like score 0 for my default text. That makes sense to me. And then you could also play with font size and actual font. And color. And one important thing to point out here is if I make my font size too big, suddenly my text disappears. If your text ever is missing, but you can still see the box, it's a very common issue. It's just because the text box is not actually big enough to display it. So you have to make sure the text box is big enough, or you need to make your font actually smaller. All right. So once you have a score text box you're happy with, we can now finish the apple. We'll see that it's missing this score text. We can click and drag our score text and drop it into that empty slot. And now once you have an apple and a score text on your screen, such that the apple has a score text, a player trail render, and respawn bounds, you should actually now be able to pretty much play Snake. So if I start my game, the apple will immediately randomize its position. I can then move my snake to pick it up, and it doesn't work. Dang. Don't worry, this is on purpose. It's another teachable moment. But the reason this doesn't work is for one very simple thing. And it's another sort of weird one. I'm not exactly sure. It's another one that I'm not exactly sure why the game developers did it this way, but it is what it is. So if you click on your apple is currently a collider. It has a circle collider on it, but it actually needs to be a trigger. So if you look at your circle collider 2D, you see this is trigger right here. There's a little checkbox. If you click that, your game is actually now going to work totally correctly. And I'll tell you why in a second. But now if I hit play and I run into my apple, my snake will pick up the apple. The tail will actually get a little bit longer and the score text will get updated. Nice. Except I can't collide with my own tail. All right, so let me talk about triggers really quickly, and then we're going to add collisions to our game so that we can run into our tail, and then we're done for the day. Wow. So a trigger versus a collider is an age-old sort of weird distinction. Can anybody actually, this is another good moment, anybody tell me or guess what a trigger is versus a collider? Just based upon the name. Oh, sorry, Ella. Did we remove the rigid body from the snake? Oh my gosh, that must have been ages ago. Hopefully you figured it out. So we didn't remove the rigid body. We actually just turned the gravity scale to 0. If we click on the snake, we look at the rigid body, and there's a gravity scale. Currently mine is 0. I've been missing a bunch of chats. Sorry, y'all. So for the trail render, I first of all right-clicked on the snake. I created an empty object underneath it, which is this tail here. And then I went down to add component, clicked add component, and I searched for a trail renderer. Once I did so, okay, great. Once I did so, I changed the time to be 0.5. This is just how long that tail is. This is going to be how long it starts at. I then changed the color with some gradients. I then changed this width by double clicking and adding another thingy, another spot. And I added a material. In this case, I used the default line material. There's a little drop down here for materials. You can always look at the video recording afterwards too. It should be up in the next 2 days or so. Zoom takes a second to compile it for us. Okay, no problem. All right, so the trigger is the action that occurs when it interacts with the collider. Very interesting, not quite. Trigger is like a trap, it activates when you interact with it. Yeah, so almost. These are both great explanations. A collider is in the name. It's a thing that collides. So if my fists have colliders on them, they run into each other and they stop. A trigger is a little bit different. Got a scratch in my throat, too much talking. A trigger is instead something that doesn't actually collide. So my hands, if they were triggers, would pass straight through each other like a ghost. But they still register that collision. They still know that they are passing through each other. There are use cases for that that are important. So if we're playing Zelda Ocarina of Time, and we're about to walk into the very first boss fight with Goma, and we walk through a doorway, that doorway probably has an invisible trigger inside of it that detects that Link is walking through the doorway for the boss fight to actually start. But that trigger, we don't want it to actually stop Link. We don't want Link to get stuck outside the door. So we still want to know that he's touching it, but we don't want it to actually run into him. That is the difference between a trigger and a collider. The only reason that our Apple didn't work as a collider, if you open up the Apple script, you'll see that, and don't be too scared of this, half of these lines of code are me leaving comments for you to hopefully understand later. But you'll see that we have another built-in Unity function, just like start or update, called onTriggerEnter2D. And this just means this function will get called when we run into this thing for the first time. And not for the first time, just whenever we run into it, it's going to get called. If this was on collision enter, it would happen whenever we run into a collider. But because it's on trigger enter, it happens whenever we run into a trigger. So the apple as a collider will not do anything, but as a trigger, it will actually get activated. I've always felt that that's a little bit weird, and it feels like those should just be two separate types of components. But once again, that's kind of how it is. You just got to learn those little intricacies of how this all works. But we should now have a functional version of snake. So another great check-in moment. Does everybody have a snake that can move around and pick up the apple? Any problems? Let me know. We're almost there. Final yes. Great. Awesome. Okay. So the last thing we're going to do is drop some poop. This is really weird and is a creation of mine, actually. Something that I invented as a way for us to detect collision on our snakes when I was trying to figure out how to do collision detection for you guys that wasn't going to be too complicated. Because in the real game of Snake, it's actually grid-based, and it will like draw that many grid pieces on the snake. But that's sort of that's like a data structure that's complicated enough that it would be a lot to try to cover in 2 hours. So I was brainstorming on how to make collision happen for this tail, even though we don't have a real grid controlling our snake. And here's what we came up with. So there's gonna be a couple of steps that I'm gonna ask you to do before we see this actually working. First thing is I want you to click plus in your hierarchy, go down to 2D object, go down to sprites, and then circle. So make another circle in your game. Goodness, my circle is way out in the middle of deep space. I don't know why. I'm going to reset that to 0. And then I can always double click to come back to my circle. I'm then going to make my circle quite small. So make it smaller than the snake. This is your snake poo. It doesn't matter what this circle actually looks like. We're going to make it invisible later. We're going to keep it visible for now so that you can see how it works. On my, my circle, I'm going to rename this snake poo, or if that's detestable to you, you can name it something else. I'm then going to click add component, and I'm going to add a circle collider to this thing. And it does want to be a collider. It does not want to be a trigger. And then I'm going to click add component, and I'm going to add a snake poo component to this script. To this object, excuse me. So I made a snake poo. I have a sprite renderer on it with a circle. I added a circle collider 2D, and I added a snake poo component that I wrote for you. This snake poo component needs one little bit of setup. It needs to know about the collider. So I can click and drag this collider and drop it into this empty slot as well. Make sure you do that. All right. Now, we're going to turn this thing into a prefab. Now, prefabs are another topic that are super valuable and super in-depth in Unity. So the Indie Game Academy runs programs just like this, but much more in-depth. And our level 1 program is entirely recorded. It's 17 videos long. And in that program, we'll go much more in-depth into prefabs. For today, I'm going to show you the absolute minimum just because I want us to get this working. So in order to make a prefab or a prefabrication, we can click and drag anything in the hierarchy. So in this case, I want you to click and drag the snake poo and drop it straight into your assets in the project. If you do it right, you'll see that snake poo becomes blue, like highlights in blue, and you get a snake poo asset in your asset folder. And now this is why prefabs are awesome. If I click and drag this snake poo into my world, we can make a bunch more of them. And they all have the same values on them. They all have the correct setup. Now, we don't actually need these. You can delete these now because we're actually going to have the snake automatically create them into the world. For the sake of time, I'm going to not write this out. This is something that, by the way, don't worry about the fact that we wound up a little bit behind today. It's first of all because I messed up all of our tech stuff, but we always sort of fluctuate in how far we get in these classes. They're intentionally designed to allow some space. But for the sake of time, we're not going to write this next section of our snake yet. We're not going to write it ourselves. We're going to copy and paste. So what I want you to do is open up your completed snake script. If you don't have that, you should have downloaded it from the Google Drives folder. So open up your completed snake script. And I think it will be simpler for us to just use the completed snake script instead of copying and pasting a bunch of stuff, since we're almost at the end of the session. But I will point out some of how this works. Let's get it working first, and then we'll talk about the difference so that you can maybe write this script for yourself later by looking at this code instead of just using the one that I have written for you. But once again, I've said it a million times now, for the sake of time, let's actually just use the completed snake script. So come to your snake object in Unity, come down to the snake script, and we're actually going to remove this script, this component from the snake, and we'll use the completed one instead. So click the three little dots at the top right of the snake script and click remove component. And then click add component and search for completed snake. The way that we do these classes is we try to give you just enough to understand how the code works, but then the rest of the scripts we always have ready for you just so that you can copy and paste and get your game working quickly. And then from there, hopefully you can keep exploring and keep expanding. So remove, actually click the three little dots, click remove component on your snake that is already attached to your snake, the snake component, and then add a completed snake component. This needs a little bit of setup. It needs to know about its mover. So you can click and drag that mover into that empty slot. It needs to know about its own trail render. So you have to click and drag the tail from underneath it, that game object, and drop it in there. And it needs to know about the snake poo prefab, which we can actually click and drag from the project into that empty slot. So I said that all a bit quickly. I'll say it one more time, a little bit more slowly here. I removed my snake component from the snake. I added a completed snake component to the snake. I attached my mover by clicking and dragging this component. I attached my trail render by clicking and dragging the tail game object from the hierarchy. I dropped my snake poo into this empty slot by clicking and dragging it from the project. And we now actually have a fully functional version of snake with 10 minutes to spare. We have one more change that we'll make, but let me show you how this works. So here is our very interesting and unusual method of collision. You'll see that there's this little white ball that gets dropped behind me and then destroys itself after some time. And if my snake gets longer, it drops more balls. So what's actually happening is it's literally just dropping a ball in space, and that ball is no longer connected to the snake at all. And for just a moment, that ball is not allowed to collide with the snake. But then after it spends just a moment not colliding, it is then allowed to collide with the snake again. So that now this ball, it will actually run into its own tail. It will actually run into that little ball that it dropped in the world. So this is our really unusual way of running snake. I've definitely never seen somebody code snake in this fashion. But like I said, this was an attempt to create a version of snake that we could understand with very little coding experience and that we could make in 2 hours. So that's how I also think that this is a great example of how game engineers actually solve things. This is a really unusual solution. This is not something that you would have typically programmed into your game, but it is a functional solution. It does work. I can run into my own tail and I die. And this makes my game a little bit unique. It makes it so that I don't have grid-based movement. I can move my snake along a perfect 45 degrees. I'm not locked into the grid, I'm saying. But it still gives us that exact same feeling of being able to run to that tail that I have to avoid as it gets longer. So let's do 2 last things. These are just gonna be quick changes. First of all, the snake poo is currently white, which looks weird. We can make it transparent so that we don't actually see it, but we still collide with it. This is another reason that the prefabs are awesome. I can actually still edit this prefab even after it's gone from the scene. In order to do so, I can double click on the prefab in the project, and it will actually open the prefab by itself, almost like it's its own scene. And then once I have that open, I can click on the color of the sprite renderer, and we'll see that we have an alpha channel, which for any artist in the room know that that means transparency. So if I move that transparency all the way to the left, it will effectively make those little white dots completely invisible. And I don't need to do anything else. I can click this little back arrow at the top left of the prefab. That will bring me back to the scene. My little snake poos are now completely invisible. I now have a version of Snake, and the player is none the wiser. They have no idea that this weird little solution is happening right under their noses. And then the very last thing that I'll do, just because it's kind of ugly, we noticed that the trail is way too wide for the snake, just in case anybody missed it. This curve is what controls that width. So at the top of the curve here is the start of the trail. I'm going to make that a little bit smaller. So I'm going to move that down to, I don't know, what does a 0.5 look like? Let's see. There we go. That looks a little bit better. Maybe it's even too thin, but you know, it's not a big deal. Up to you on how you do it. Okay. So that is a completed version of a playable version of Snake, of a functional version of Snake. Does anybody have, first of all, any problems? Is there anyone who is behind or not having stuff work? Or does anybody just have questions? Are they curious about anything? Okay. Let me know if you do have issues. Let's see, let's do a couple of things here to close down. So first of all, my name is Willem Delventhal. I've been your instructor today. Hello. It is 78 degrees in Malibu and sunny. I don't know. I am a teacher, creator, game developer, and I run what's called the Indie Game Academy. We basically run programs for people, and we run programs to teach people how to make games, and in particular, we teach people to publish games. Our whole sort of philosophy on gaining an education is publishing and releasing games is better than anything else you can do. You, one, are building a portfolio, and then two, you are going through the entire process instead of just like sitting and grinding on the same problem forever. So we have 3 programs, level 1, 2, and 3. If you check out level 1 on our website, that is definitely the best next step to this. If this felt like, you know, just a little bit challenging, level 1 is good. If this felt like a total breeze, you could look into level 2 or 3. In level 2, we take you into sort of a live game dev classroom. You go through 1 month of live classes just like this, 2 classes a week, where we actually build you a platformer game, so a classic Mario game or something like that. You get to customize it, and then you finish by releasing that game online. So you actually release that game, you finish that game. In level 3, that's our crazy like bread and butter. That's the one that I love the most. Imagine like Hogwarts for game developers. You actually work with the team, run your own indie studio, ideate, come up with an original game concept, build that game with your team under the guidance of myself and 6 other professors, and then actually publish that game to a store of your choice, iOS, Android, Steam, etc. And you monetize that game as well. So if any of that sounds interesting, here is my email. That is for you to reach out to if you just want to chat about stuff too. So I am, you know, of course, open to talking about our programs, but I am also just available to like talk about life, how to break into the game industry, how to become an engineer, whatever the heck you want. I try to be available for people because I've had so many people help me in my life. So if you just need some help, let me know. If you want to join our programs, of course, let me know. If you want to chat with me in person, and definitely if you want to join, thank you, Mohammed. And definitely if you want to join, that is my Calendly. You can set up a call with me, 30 minutes, and we'll talk about life and such. And the last thing is I'm gonna give you a gift, y'all. So if you want, you can join our Discord. We love making great games. You can click that link right there. And if you type in this custom command, you actually just finished what we call our level 0 program. So if you go into our Discord, type that custom command in any channel, you earn the level 0 role. Congratulations, you did it. Everybody in programming knows that we start at 0, not 1. Yeah, good job, Mohammed. All right, y'all. This has been a pleasure. Thank you so much for your time. Please feel free to reach out. I really do try to be available. In the next 2 days or so, when the recording has finished processing and we put it up on the YouTube channel, we will send you a recap on the class, links to the recordings, as well as the assets and stuff like that. That's it, though. Thanks,
Thank
y'all.
you.
Of course. Thank you. Take care. Looking forward to talking to some of you. Have a great rest of your day.
You.
Goodbye, everybody.